Okay, we're live. Let's see if this fucking works. Fortunately, once I do the presentation, I can't use any other.
I can sit on the other side. I can sit on the other side.
No, it's not so much that, it's just that I want to verify that this actual screen is being shown on the live presentation and not my other desktop. That's nothing's there. So, actually, maybe, actually, I can look at it. All right, awesome. Thank you, Andre. You can hear us, but we can't hear it. All right, so let's. All right. So, welcome. This is a presentation on my iopipe library. Uses direct buffer access to enable more optimized usage of buffer data. So, first thing to remember about IO is that it's slow. When you're moving data, from device to memory, mechanical devices are slow, like hard drives, everything is slow. Anytime you make a copy, you're wasting CPU cycles. And there's plenty of places that we do that, device to kernel, kernel to user space, and inside libraries. You could do it, multiple layers of libraries. So we need buffering. It's obvious. It's necessary for performance. Using it as an optimization. So if you just have, like, for instance, reading a byte at a time or processing a byte at a time, using buffering as an optimization for that is wasted, because you could have access to the whole buffer, but you're just looking at one byte at a time. And if you change your way of thinking to look at the whole buffer at a time, it's liberating. There's so many more things you can do. As I said before, every copy counts. The CPU is wasting cycles, moving data here and there, and the performance is trumped by your API correctness. So you want this interface to, give you a byte at a time, but you don't care about the actual buffer. But it's an API problem, not inherent in the, the way the buffering is. There's this thing called zero copy, which Linux and other OSs support. Basically, read from one device into a buffer, and then write to another device right out of that buffer. So you're only making one copy. And the problem is that there's no user space code allowed. So you could say, let's say you're serving a web page, you could say, okay, read it from this file and then spit it out to that socket, but you can't do anything with that data. But it shows how avoiding copies, can provide incredible performance. You can get like 75% performance increase by doing that versus reading it into your user space program and then pushing it out another way. The problem with that is that most data, you want to do something with it. You don't want just straight copies. It's boring. Sometimes it needs to be augmented, like if you needed to replace text in the stream. If you, adjustment translation, so if you're like doing compression or decompression or byte swapping bytes, you need to do that somewhere. It can't be done in the kernel. You have to do it in your user space program. So, and, let's say you were, uploading a file and you wanted to write it to multiple files. You couldn't just tell the kernel to do that. You have to do that yourself. So there's all kinds of reasons that you can't use the zero copy approach. You got to pull it into your user space. So if we're going to do that, we might as well make the best we can with it. So a use case of this is the byline function in Phobos. Basically read data from a stream or whatever until you see a line ending, and then provide the line data to some function that uses it to do whatever, and then reuse the buffer for the next line. You leave the rest of the data on the stream. So that's kind of like the byline function in Phobos. It's a range. If I'm going too fast or whatever, just let me know. Okay. So the file star API solution, which is C's solution, basically buffers data for performance reasons, still is one character at a time. There's no access to the buffer, except we have these little shortcuts like get line and get delim, which allow, because the C standard library knows what's actually underneath in the buffer, it cheats. It can look into that buffer and say, oh, there's the next new line. I'm going to give you that data. And it also has no real good Unicode support. There is like a wide character support, but it's just for there's Samir. So pause for a second, wait till Samir gets in here.
Nice.
All right. Welcome.
Start?
Yeah, not too long ago, about 5 minutes ago. I just was going over like the different things, the reasons why you would want to use. Oh, this is an in-out.
Oh, this is not enough?
This is not it.
Oh, what is
This is my iopipe library.
Oh, nice.
So different reasons why you'd want to use direct buffer access versus just using buffering as an optimization. So if I'll just go back one slide so you can see here.
Yeah. The other day I saw went through the page.
Right.
I liked it a lot.
Right. So byline is basically read one line at a time.
Right.
Read the stream until a line ending's found. Give the line for processing, and then reuse the buffer. Excuse me. So file star, which is the C API solution, has the problem that we're talking about. Basically fgetC is your one interface. You can read, you can do a raw read or whatever it is. I can't remember what f read or something like that, and it gives you so much data, but you can't, if you find your line ending there, you have to do something with the rest of the data. You can't put it back in the stream. That's why you use fgetC.
Using buffer, you have to feel how much you want to read per time.
Yeah, you have to read that much, and you can't put any back. fgetC allows you to read one character at a time. You can put one back. That's about it. But we have these shortcuts, get line and get delim, which actually know how the struct is implemented underneath the opaque file star struct, and can look at the buffer data directly, so they can optimize off of that.
Oh,
There's no.
It's still using the same.
Right. Yeah, it's in the same library. It knows the implementation. So, but there's no real Unicode support. There's wide character support in some operating systems, and some there's not. And even then, it's not really like true Unicode. And even UTF-8, it doesn't understand that at all. The problem with Phobos is it actually uses file star as its underlying stream implementation. So the file type uses those tricks, get delim and get line.
Sometimes it's hard for me to imagine sometimes how these things under the hood are.
Oh yeah.
I must be using so many. Cannot really get everything.
Right. So the code for byline in Phobos is 520 lines of code. That's just for byline. We have basically 4 different implementations. There's one for POSIX code with get-delim support, which uses that to shortcut. That's on OS X, FreeBSD, Linux. There's a Win32 implementation that is specific to DMC's library, knowing what the underlying struct layout is of the file star.
DMC.
DMC is Walter's C++ compiler. Right. Then there's a default for POSIX, which has some support for some reason for the WCAR. Like if the stream is in wide mode, it does something different than if the stream's in narrow mode. But it's still it still uses the fgetc. Just give me a character until I find a new line, and then I'm going to return it. But
Andre is not online, is he?
he is. He's actually listening.
He is.
Yeah, we're streaming this. He's not talking back then. And there's a default for Windows 64 because Microsoft, when you tell it to go wide mode, it just ignores it. So, so even if it'll say, yeah, you're in wide mode, but it doesn't do anything differently, which is really terrible. But that's what they do.
They are funding the Linux Foundation.
Oh yeah. There's other limitations. FileStar assumes that you have shared access to the FileStar, so anytime you do any operation on it, it requires a lock. There's no inline capability, so when you call fgetc, it's actually calling a function. There's just no way.
Can I ask a high level question?
Yeah.
What is your IO? What's it called again?
iopipe.
iopipe. Is it a replacement for a file? Kind of.
Not exactly.
Okay.
We'll get to that.
Okay. Because when I read pipe, I understand something.
Okay.
Okay.
It's actually more descriptive of the way that you can set it up as a pipeline.
Okay.
The other thing is it requires a file descriptor as a source. So if you just wanted to do byline on a string literal, you can't do that. Because file requires you have an actual file descriptor.
Oh.
The other thing is that DMC libc has a 64 file descriptor limitation. So that's the most file descriptors your program can have open. There's also some other limitations, obviously.
I wonder if it is going to go anywhere like the pipe. Have you heard of this thing called pipe? PYP?
No.
And it's amazing. It's like pipe in Python.
Okay.
But I'm wondering if
it might be something.
It's really slow when you want to do something.
It's really slow.
It's because it's all interpreted, right?
Oh yeah. Okay.
And
this is going to be better.
I know. That's what I'm saying. So I like that for the interface perspectives, but then when there's a lot of things, I end up going off.
Right.
But this might be a good replacement for that.
All right. So iopipe, which is my library, takes a different approach. So we provide direct buffer access. We don't hide anything. You want access to the buffer. That's actually the interface. There's no give me the first character or whatever. Or there's nothing like that. There's no actual stream position inside your buffer. It's just here's the buffer.
So you still have a specified buffer.
You have it manages the buffer. So you don't specify the buffer. You tell it.
Okay.
You tell it how to manage the buffer, and it gives you it takes care of everything for you. It's all decode. So the API and inlineable. So everything is basically templates and can be inlined by the compiler to can compile the best way possible. All the text iopipe code, which includes detecting bombs and dealing with different Unicode styles, is 519 lines of code, including unit tests and comments. Compare that to Phobos' 520 lines of code that's just byline without unit tests and comments. So it's much simpler. And the reason mostly is because Phobos has 4 different implementations to deal with the 4 different shortcuts. We don't rely on C shortcuts and the limitations thereof.
But you can build on Phobos, so it's using something from Phobos.
I'm not using anything from Phobos
for
iopipe, no. But I'm using Allocators. So it does support allocators. So when you're managing your buffer, you actually provide an allocator that says, this is how I want you to allocate the buffer.
It's still in runtime, right? I guess it's not.
Yeah, of course. Yeah, it uses the runtime. It uses the garbage collector. It doesn't.
But that's.
But it doesn't depend on them. It's just, you know, it needs some way to allocate memory and stuff. So
Right.
we do depend on the runtime indirectly, but you could specify, you know, use mallocator. And it has full Unicode support. I support all forms of UTF that I know of. Except I think somebody said there's like UTF-7. I don't know that one. I don't think I support that one.
If it fully supports UTF-8, I'm happy.
UTF-8, UTF-16, both big and little endian. UTF-32, both big and little. So five major stream types, and it's twice as fast as Phobos. So just with basically a different approach, we can achieve a much faster.
I do so much stuff on the pipe on a daily basis.
Yeah. So hopefully this can.
Write a wrapper.
Yeah. It's not like, it's probably not ready for prime time,
Right.
but it's the concept-wise is pretty cool. I can show it to you after you know, how some of the things that I did with it. So here, this is the API. It's very similar to ranges. You know, range, you have front, pop front, and empty. Window gets you the buffer. So this gives you the access to the buffer. This is like front from a range API.
I've always been confused about ranges. This is a good time, maybe it's not. But is it the way I understand ranges is like iterators?
It's like iterators, yeah, but it's like a pair of iterators.
It's a pair.
It's like you can think of it as a pair of iterators, a beginning and an end. And,
I see.
And front gives you the first element that's pointed at by the beginning iterator.
Oh, I see. Okay,
And
got it.
empty is like, you know, does the begin equal the end? And
Oh.
then pop front means, you know, advance the
So
front.
iterators, you don't need to have two at a time, huh, in C++. I have.
Yeah, you usually have two at a time. There are certain cases where you don't, but, you know,
But ranges have.
ranges always have two at a time. So the window function gives you, or window accessor field, whatever, gives you the current data and that is a random access range. So the requirement is that it has to be a random access range. It doesn't have to be an array, but I think that, and I haven't tried this yet, I have thought of making buffer types that are like a circular buffer. And I think that the cost of accessing individual elements and having it check, oh, is it in this segment or that segment, and that code under there is going to kill any performance gains you get from not copying the data around. But I think it depends on the application. Like for instance, a byline, most of the time you have like this giant buffer, and once you get to the end and you run out of lines, you only have to copy a little bit of data to the front.
Yeah.
So you're not really losing much by, or gaining much by having a circular buffer where the whole time every time you access one element, it's like, oh, is it in the front or is it in the first segment or last segment?
I see.
So, but it does support any random access range. The second function is extend, which extends the range window, basically pulls more data in from the source and extends the window further. So you can either tell it, I want you to get me this many more elements, or you can pass a 0, which means just whatever the source thinks is a good amount to read. And the reason I have that is a lot of times you have a buffered file or a buffered stream or whatever, and you don't know what the size of the actual buffer, like the allocated space is. So you're just telling it, just fill up, you know, as much as you can. And so the code is kind of built around, you know, doing that. Most of the time you're extending with a 0. But there can be cases where you say, oh, I know exactly how many more bytes I'm going to need. Give me that many more bytes, and it'll do it. And
You said something about random access? You also asked? No.
The window is random access. So the buffer's like an array. It's a random access range. So random access range is
Within the window, it's random access.
right. It just allows indexing. You know, what is it? Constant time access for indexing. That's what it is. And then there's finally release, which just says, okay, I've processed all this data at the beginning. I don't need it anymore. I'll give it back to you. You can do whatever you want with it. And that's basically, you know, it's like pop front. So extend and release is kind of like pop front and empty, but in a different way. You know, when you extend and you get 0 more elements back, that's like end of file. So that's like empty. Note that for the purposes of my library, I consider character arrays to be random access ranges because it's really painful to deal with.
Yeah, because a character in D means Unicode.
A character is a code unit in D,
Right,
so technically it's not supposed to be something like a character. And
right.
all of Phobos treats like char arrays as not random access ranges, but it makes it really difficult because then you're translating to bytes or ubytes or whatever, and you know you can't use string literals. It's kind of a pain. So just for simplistic purposes, I consider it to be a random access range, and that does kind of suck in some ways because, like when I'm testing, making any kind of random access range, one thing I did was chain 2 strings together. Well, now it's not a random access range anymore. So it kind of causes problems.
Because of that, right? I didn't really realize it that much.
Overhead because of the
Because character is actually just to deal with the
well,
decoding or auto decoding.
yeah, it's the auto decoding thing, but it's not really auto decoding. If you access one element, you're not auto decoding. But for the case of iopipe, I don't care. I'm not trying to decode or anything. I'm just trying to provide some buffer.
The whole discussion, there was long discussion on auto decode.
Yeah. There's lots of long discussions on auto decode. So this is kind of like the pseudocode for byline in iopipe. We check and see how many elements we've checked already. Try and get some more. If we get 0 more bytes, then we're done. That's the end of the stream, and we'll return that. Otherwise, we look in the new data for the delimiter we're looking for. If we find it, then we return that line, and if we don't, then we keep going. We just keep going and extending our buffer until we find a line.
The next line is byline kind of?
This is like
inside the byline.
This is like pseudocode for how the iopipe byline works.
Okay.
But it's really simple, straightforward. It's cross-platform. It's fully optimized based on the element type. So the element type in here could be character, it could be dchar, it could be wchar. And it's agnostic to the input type of the buffer type. Compare that to Phobos file, which requires a file descriptor and a byte stream.
Sorry, I'm lost here. Why new data equals byte.extend 0?
So what I'm trying to do is there should be an extra set of parentheses there. New data should equal the pipe.extend 0, and there should be parentheses around that. We're checking to see if there's end of file.
Oh, right.
So rather than doing it in 2 separate lines, I did it in one line, one expression. But I should have an extra set of parentheses. Thank you. I'll fix that later. So yeah, it's checking. New data is just basically saying how much data did I get. So new data should be, if it's 0, it means we didn't get any more data at the end of file. If we did get some data, then we want to check that new data to see if the delimiter is in there.
And the delimiter position is.
Delimiter position is just in some pseudo function find delimiter, which is basically saying, do I see the delimiter in this data? And if so, where is it? And anyways, the real code is different, but this kind of gives you an idea of how simplistic the code is, even though it's like, there's no like super really all the optimization is in searching for the delimiter, because when you're doing Unicode, it's kind of tricky, but I did get it to be twice as fast.
So you probably have to search for Unicode and all delimiter.
I'm looking for a Unicode character, a Unicode code point, so it could be multiple characters. And there's definitely a lot of stuff involved in making that as fast as possible. But the nice thing, as I said, is it's completely agnostic to the input type, buffer type, fully optimized based on the element type. So we have lots of cool stuff we can do there, as opposed to like fgetc, which just gives me a character. The other thing is that iopipe byline is an iopipe, so it's not a range like Phobos byline. There, I have a function as input range, which basically wraps any iopipe into a range, and all it says is the current element is the whole buffer that you get from window. If you pop front, it drops all those and then extends more. And all byline iopipe does is when you extend, it just reads the next line. It says, I'm going to extend one line more. Imagine you could have like a byline range with the two previous lines as context, or the two previous lines and the two next lines as context. So you can have that kind of flexibility when I do it this way. So it's instead of this, one line at a time, I give you have access to the buffer, you can do whatever you want. So this is the kind of thing I'm talking about when it's like, it's kind of liberating being able to access the buffer at any point. All arrays are iopipes. So this is the complete implementation of turning an array into an iopipe. An array is like a dynamic array in D. So it just basically says, it makes it so any array can be an input iopipe to some other.
I see, sorry.
So
yes,
essentially, an array is a non-extending. It's end of file immediately because the array is the buffer.
Arrays can be.
They can be added, but what is that data?
Right.
It's garbage, or initialized. It's nothing interesting. So this is the default implementation. There is a way you can create an iopipe that.
Somehow I guess it confused about this extend and release. Pop. Extend is equal to pop. Front?
Extend is not equal to pop. Extend and release are kind of like pop front and empty, but not direct mapped. Extend gives you more data on this side.
Right.
Release pulls data off of that side. So the operation is not a direct mapping, but it's similar. It's similar.
I think I understand now.
Okay.
Because pop front is it's like a stack. It's not a
Pop front just says give me the next element.
Right.
Forget this element and give me the next element.
Right.
So you can implement pop front in certain ways.
Yeah, I see. Yeah.
What's nice about this too is it makes testing very, very easy. I just say, here's a string literal. It's an iopipe. Go, test the data out of it. So the test for byline, I don't need to set up any file streaming or anything like that.
Wow. That's nice.
I just say here's a string. Iopipes use chaining, so I don't know. This is kind of hard to see, but not on this gigantic like 80-inch screen, whatever this is. So you have, just like range pipelining, we do the same thing. So the first one is, okay, let me read this file as UTF-8. I'm going to chop it into lines, and then I'm going to make it an input range, and that gives you the lines. The second one takes a compressed file and decompresses it, and now same thing. You just pull it out. It's the same thing, but with an added decompression step in the pipeline. And then finally, from a literal, as I was talking about, you just here's a literal, and it'll do byline. Now this I don't have to do as text UTF-8 because it's already character. As text basically just converts whatever the input stream is into that with character stream as a direct conversion, like a cast. It's like a cast. The compression and decompression does have to actually allocate a separate buffer, but that's all handled internally because when you decompress or compress it. It changes the size of the actual buffer.
And these are how this wonderful thing happens because of UCS, right?
Yes, UFCS is awesome for this.
UFCS, not
Yeah, yeah.
UCS.
Universal function call syntax. Yeah, no, this is great because basically it allows the compiler to see everything in this whole pipeline and optimize it exactly. Inlining, everything is all done. And one thing that's nice about it is, as the programmer, you can say, okay, optimizer, it's all on you.
Yeah, no,
I don't have to do any optimization. If it's not optimized correctly, that's on the compiler writers.
I like it so much because of how, I mean, it's almost works like pipes, right?
Oh yeah.
I mean, even without.
No, it's great. This is
pipe.
the only thing that's kind of bad about this is it's all needs to be decided at compile time. Like if you're reading, let's say you're reading a file, you don't know what width it is. You have to look at the BOM. Now you have to create, 5 different instances of the pipeline, depending on what the BOM comes out to be. Because you don't know what it's actually going to be until runtime. And I do have a program I can show you afterwards that deals with that. But and I want to make it a little bit prettier, but it's not that pretty right now. But it does work.
Anything you do with text is you read by line, I guess, most of the time.
A lot of times, yeah, you read by line. But you could read, let's say it's XML file or something, you read by element,
And again, if you substitute byline, the original byline.
Yeah. So this first thing where I say buffered file as text UTF-8 byline as input range is like twice as fast as just like Phobos' byline.
Right.
So just doing, it's pretty simple. Obviously, I want to make some consolidation here of like, some of these things. This doesn't work. I'd like to make some more nice, wrappers for some of these things, so you're actually don't have to put as much stuff in the pipeline.
I guess I'm surprised that byline is that this can be twice as fast as byline. I would have thought byline is such a commonplace thing that it should be pretty often.
Well, it's the problem is, like I said, the locking, you don't have inline capability and you don't have buffer access. And the other thing about Phobos is returning you a garbage collected line, whereas the underlying C code needs a malloc buffer because it's going to do realloc on it. So it necessarily has to make an extra copy. So actually, Phobos' byline is probably even slower than it could be because of that. And my byline may not be as fast as the actual get line function, but I haven't tested that yet. Output. So iopipe output is harder. Output needs to be pushed, not pulled. So far, everything we see is pull. So you just basically, you see the end of the pipe. You don't see the beginning. Iopipe strictly uses that pull mechanism. I don't want to make push versions of everything and change, how the interface works. I like the extend release window interface. That's great. That it's nice, easy to wrap, but we need to do output, obviously. So how do we access the source element in the chain, the very first element? So the weird way I came up to do this is called valves. I call them valves. So if you think of a pipe, a valve is like a control point along the pipe. So if you had this long pipe and you had some valves along the way, they change the way things are flowing. That's why I called it a valve. So it's just some control point along the chain that allows direct access to that point. All iopipe wrappers must provide access to the next valve. I have an easy mixin you can just include in your wrapper. So if you don't care, if you don't want to deal with valves, you just say, here, just mix in a valve, and depending on whether my upstream iopipe defines a valve, it'll provide access to it or not. So if you don't have a valve upstream, then using the valve member will just be a compiler error. A push iopipe this is like the most confusing part of this. A push iopipe is really a pull iopipe with a wrapped holding valve. Now, a holding valve this is how I figured out how to do output. A holding valve has an upstream pipeline, a holding area. So when you release data from the upstream pipeline, it goes into the holding area. Then there's the downstream pipe. When the downstream pipe calls extend, it can only pull data out of the holding area. So it just basically divides your buffer in half and provides this like lock, kind of like a lock in a river, whatever. So that, you know, this guy pushed data into the lock and this guy pulled it out. Kind of like a producer consumer, and the data doesn't move, it just stays in one place. So in this call here, the null stream is basically giving it's like a source. It's an unbuffered source that just basically gives you garbage. So it's just so you can use the buffered input. So the buffered input is going to create a buffer and say, okay, I'm going to read from my source, and the null stream says, yep, there's data for you. It doesn't actually do anything, but it just pretends that there's data there. That's your output buffer. So that's where you access what you're going to write to the stream. The holding valve provides that lock there, and then we cast it to a iopipe because the output file requires that. That's something I want to fix so that it doesn't require that extra piece there. And then you call the holding loop. The holding loop basically only provides access to the upstream valve, like that's what you were pointing at. So even though you only have access to the end of the pipe, you're actually writing to the beginning. And I didn't have time, but I do want to make a picture or something that shows like how this works, because it's hard to conceptualize, and it took me a while to think of this. But basically, if you look at this, it's just like you're writing. So when you write to that window, you're writing to the buffered input, because that's what's upstream of the holding valve. Then you release that data, it goes into the holding area, and then when you do an extend, it's going to actually first tell the downstream part, okay, now I'm going to pull all the data out of that holding area, and the output file, as soon as it pulls data out, writes it to the file. So that's what its processing does. Now you could actually have more things attached to that output. You could output it to several files or whatever. As you extend from each one, it will, write them all or do whatever processing. But that loop at the end basically closes that whole thing and automates that part. So it kind of becomes like a push instead of a pull. I know that's confusing, but it does work. Valves don't need to be automatically pulled with this, loop and stuff. It's just some way to access an earlier part of the pipeline. So I actually have a simple valve which just gives you access to an upstream part. But that's valves. And so the future. So what are my plans for the future for this library? Right now it's kind of like a toy library. It just has very rudimentary support I believe it's only in POSIX systems for file reading and writing. I plan on adding Windows support, but that part of it is not the focus of the library. That stream part is just some, simple wrapper around file descriptors. But I do want to create like a JSON parsing library. So if you can imagine this kind of having direct buffer access creates a really useful abstraction for parsing. So you basically can look back, you can look forward, you can look at whatever data, you can use the data right out of there, especially for text parsing. So you're parsing a JSON file. There's no need for you to make a copy of things. It's there. You just say, here's the the element that's in there. You can provide that right out of the stream. Same thing with XML. I know there's an XML library on the docket for including in Phobos from Google Summer Code. I think that my code can use that code because it's basically just a stream provider. It doesn't really, the parsing and XML handling stuff can still sit on top of that. Recently, I've been doing a lot of work with the MySQL native driver that's on code.dlang.org. And there are some issues with that code. It has a few lifetime issues, and the API is kind of, it's iffy. I know Nick is working on upgrading it. Hopefully that comes out great, but I'd still like to replace the underlying socket stream and stuff with an iopipe. Right now there's actually no networking support, except for the fact that you can just provide a file descriptor. There's no support for things like, waiting, select and that kind of thing. And also in that vein, Vibe event-driven I/O support I'd like to have in there. And finally, maybe you can go into Phobos. Originally, I did plan when I started doing an I/O library, I don't know, like 5 years ago. My plan was to replace the library in Phobos, the file type, just replace the guts instead of using this terrific C wrapper. I wanted to use something that was more D related to do all kinds of optimization and performance gains. We have thread local support, which should be used 99% of the time you open a file, it's not for multiple threads. So there's no reason we have to have locking. The only time you need locking is for write line. So it's kind of a waste. And that's it. So
how do you must be reading somewhere using the underlying file though, aren't you?
The underlying file? Yeah.
Somewhere?
Yeah. I have a stream type that does that. This is the URL for the.
Yeah, funny thing is when I searched this iopipe, I found that there's a Node.js as iopipe library.
Okay, that's not mine. So that's it, and thank you for coming and watching this stuff.
Really nice. I mean, the whole thing is 500 lines.
The whole thing, no, the whole text part of it, the whole part that deals with text.
But still, I mean, I'm looking at there are 4 directories: byline, convert, unzip, zip.
No. Those are the examples.
Oh, sorry.
So if you go to the source directory, there's a buff text.
Buffer, buff pipe, stream, text pipe, traits, valve.
Yeah, the text one,
Text pipe.
text buff, whatever it is. That's the one that I said is like 519 lines of code.
So that you can do everything, if all you wanted to do is work with text, you only need this 500 lines. Is that what you're saying?
No. You still need the other parts, but the part that's basically based on text processing, dealing with char arrays, WChar arrays, all that stuff is in the buff text. It still needs the buffer part, and it still needs the stream part, and it still needs, there's actually other pieces that are more generic, like there's a byte swapping iopipe. It needs that if you need to go from whatever the endianness of the file is to your native endianness, you need to do byte swapping. So there's definitely more you need, but the part that's specific to text is just the 519 lines of code. But I mean, compare that to Phobos byline, which has 520 lines of code just for byline. So anyways, that's it. Thanks for coming.
Yeah.
I don't know if anyone else got on the live stream. All right, Andre, or anyone else that's watching, thanks for watching, and I'm gonna end the stream now.